another fairly nice proof by contradiction is the proof that there are infinitely many prime numbers. So, how on earth do we prove this? It was a very sort of Antipodean proof, not Antipodean, wrong word, very old-timey proof. So, again, we're going to start off by saying that there's actually a finite amount of primes. So assume there is a finite number of primes. So for this, we're going to call each prime number little p. So we're going to have that the primes consist of a list of p1, p2, p3, that's a beta, p4, so on, all the way up to pn, where n is the last prime in the list. Now we're going to propose a new number. So propose a new number, q, where q is equal to the product of each of the primes. So we'll have p1 times p2 times p3 times p4, all the way to pn plus 1. So because there are infinitely many numbers, we can do this. So infinitely many primes plus 1. Now, we have two cases. Either q in itself is prime, or q in itself is not prime. Well, clearly if it's prime, then the statement's pretty much ruined anyway. Because if it's prime, then it's not in the list. So it's already not in list. Which in itself is a contradiction. However, what if q turns out to be not prime? Well, if q is not prime, we have to think of the prime factorization of it. So each of the primes we've already considered is not really a factor of q. It in itself is a product of each unique prime factorization plus 1. Which therefore means it has to have, technically, a factor of 1. Because each of the primes we've considered, and when we're taking up new numbers, each one has its own prime factor composition. So therefore, because it's plus 1 out here, we have a bunch of primes being multiplied by each other plus 1, which indicates a new prime. Because a prime is a number that's divisible by 1 in itself. So therefore, if it has a factor of 1, it has a factor of q. Which, if we've assumed is not prime, that contradicts it because we now know that q has to be prime. Therefore, there is no number q, which is the final prime, which directly implies there are infinitely many primes. And that has been proven.